Students, welcome back to the session. In the last session, we stopped the problem. Okay, at this point, let us continue that. Now, at t equal to 2 minus is nothing but what? Okay, it is nothing but, just before the second switch is operated. Just before the second switch is operated, what is the current flowing through the inductor? It's nothing but the steady state current flowing through the inductor, okay, in the first case. Yes or no, all of you? The final conditions of the first switching operation will become initial conditions of what? The second switching operation. Therefore, look at this. T equal to 0 minus, 2 minus. T equal to 2 minus for t greater than or equal to 2 will be equal to, okay, t equal to plus infinity for t between 0 and 2. I hope you agree with this. Understand all of you, okay? Okay. 2 minus is nothing but what? Just before second switch is operated, what are the conditions? Nothing but what? By the time already the network has reached steady state with the first switching operation. That is why t equal to plus infinity, so steady state, for the first switching operation condition is what? T between 0 and 2. Therefore, what is that value, Nana? Here t equal to 2 minus is nothing but what? 2 ampere. Or else you draw the equivalent circuit. T equal to 2 minus, inductor is short. The switching operation is what? Not done. That is open. This is done. You get the same circuit as it is. Yes or no, all of you, okay? Therefore, I of 2 plus is nothing but what? I of 2 minus, nothing but 2 amperes. Okay? Now, what about tau? Tau for t greater than or equal to 2. Now, tell me, what is the tau? Switching closed here. Okay, let me write it here. S1 closed, S2 also closed. So what do you get here? L equivalent is 5 Henry. RTH is how much? Both are closed. 20 gone. So 15 plus 10, 25. So tau is equal to 5 by 25. 1 by 5 second. Okay, so 1 by tau is equal to 5 second inverse. Now let me find that response. I of t is equal to I of infinity. How much, Nana, you got? 18 by 5. Okay, I hope you get this. 18 by 5. That is 5 3 ja 15 and 5 6 ja 30. That is nothing but 3.6 ampere. Therefore, here it is 3.6 ampere minus 3.6 amperes minus, what is this? 2 into e power minus t minus tau. Is that all of you, okay? T minus tau. So let me just t minus tau, but t minus 2 by tau. What is the tau value actually here? 1 by 5, but 1 by tau is nothing but what? 5. So therefore, okay, minus, let me write it clearly once again, you get e power minus 5 into t minus 2. Okay, so here you got 1 by tau is equal to 5 second inverse. Okay, so what do you get here? 3.6 minus 3.6 minus 2 is nothing but 1.6 e power minus 5 into t minus 2. Now, what do you want actually? I of 3. I of 3 means you need to take this particular equation, not this particular equation. Yes or no? Because t equal to 3, nothing but second switching operation is already done. Therefore, I of 3 is nothing but 3.6 minus 1.6 e power minus 5, 3 minus 2, t equal to 3 seconds. So you just find that value. You got 3.589 amperes. This is what very clear. Okay. See, when two switches are given, this is the best approach to, okay, solve the problem. So all of you practice. I'm telling you, this is a variety of problem, different variety of problem. So please note down. Question number 10, I'm just noting down here, okay? It's just asking what is current I of t for t greater than or equal to 0. Okay? Hope I think all of you followed the earlier problem. It was very interesting problem. Okay? Two switches are given. When the two switches are given, you must be very careful. Okay? So it's very simple even if you follow the step-by-step procedure. First you find the response for t between 0 to, then find the response for t greater than or equal to 2. Then I think it's very simple to understand the problem. I've given you a simple practical example of elevator. So multiple switches when are given, when the system experiences multiple disturbances, sometimes we may be in need of finding the dynamics of the system. After the first disturbance, what is the dynamics of the system? After second disturbance, what is the dynamics of the system here? That is why in the earlier problem, when multiple switches are given, how the dynamics are changing, okay, you can easily understand, okay, with this particular example. Okay. Well, let's look at this problem which was asked in GATE. Very simple one. So far we have solved different varieties. Now let us look at the previous GATE questions, some of them. I of t, can you make an attempt? Just make an attempt here. I of t. Now what is that circuit? First order or second order? First order. There might be 3 capacitors, but there is no inductor, right? If there is one inductor, at least one capacitor, both are present in the network, then only it is a higher order network. Now this is the first order network and step input. Therefore I of t, time response, formula, simple. I of infinity minus I of 0 plus into e power minus t by tau. Now tell me, I of infinity, I would like to calculate I of infinity. What is I of infinity? Switch is moved toward B at t equal to 0. This is okay. Please note down t equal to 0. At I of infinity, the switch is at B and no source, therefore 0. Next, I of 0 plus. What is I current to resistor? At t equal to 0 plus, second step. But for that, you require first step, t equal to 0 minus. You need to calculate voltage across the capacitor. Let us treat these 3 capacitors replaced by a single capacitor. Can you tell me what is that C equivalent? Okay, 0.5, 0.3 parallel, therefore addition, 0.5 plus 0.3. This is in series with 0.2. So 0.8 in series with 0.2. 0.8 into 0.2 by 0.8 plus 0.2. So what do you get here? 0.8 into 0.2 is nothing but 0.16. This is 1. Okay, so therefore you got finally 0.16 microfarad. So now what is the voltage across this 0.16 microfarad at t equals 0 minus? That's nothing but, let us say this is VC. So VC of 0 minus. What is that VC of 0 minus? Same 10 volts will appear. When the switch is at A, the 0.16 whole capacitance here is acting like an open circuit. The same voltage will appear. How much here? 100 volts. How much here? 100 volts. Now tell me, what is t equal to 0 plus equivalent circuit? Switch is closed and this is switch is moved to B, and this is replaced by a voltage source. Yes or no? So something like this. This is an equivalent capacitance model, capacitor model, series capacitor model, 5 kilo ohm. This is 100 volt. What is this? I of 0 plus 100 by 5 kilo, therefore 20 milliamperes. Tau for t greater than 0. C equivalent 0.16 microfarad. RTH for t greater than 0, the switch is at B. RTH 5 kilo. Tau nothing but 0.16 into 5 into 10 power minus 6 into 10 power 3. Again 10 power 3. Okay. So what do you get here? What do you get? 10 power minus 6, 10 power 3, 10 power minus 3. So 5 6 ja 30, 5 1 ja 1 plus 3, 8. Okay. What do you get here? 0.8 into 10 power minus 3, or else 8 into 10 power 4. 1 by tau is nothing but minus 4. Okay. 10 power 4 divided by 8. So 10,000 divided by 8, nothing but 1250. Yes or no, all of you? This is second inverse. This is second. Substitute this in the formula, that is this particular current formula. So what do you get? I of t is nothing but, okay, 20 milliamperes. 20 into e power minus 1250 t milliamperes. That's it. Do this, very simple one. Not a complicated one. It's very, very simple one. Note down that. Meanwhile, I'll give you another problem. Just note down another problem here. Note down quickly. Very simple one. Question number 11. I of t for t greater than or equal to 0, which was asked in gate. T equal to 0, the switch is operated. $15 millihenry, 10 ohm, 10 ohm, 10 ohm, 1.5 ampere. What is I of t for t greater than 0? Okay. This is also a very simple problem. First order circuit, step input excited by I of t is equal to, same formula you can apply. Yes or no? Same formula you can apply. Now let me apply the same formula here. Let me apply the same formula here. So let us take the same formula. I of t is equal to I of infinity, right? What is I of infinity? What is I of infinity? I of infinity is nothing but what? It is closed and is shorted. And all these three will become what? Parallel. Is it required to draw the equivalent circuit? You can visualize the network. Yes or no, all of you? Okay. Well, so this is short, this is closed. 10, 10, 10, all are appearing in parallel. Now you are in need of finding the current through the 10 ohm. Therefore, I can say it is 1.5, but three resistors are in parallel with equal values. Therefore, equally divided. That is 1.5 by 3, 0.5 ampere. Next, I of 0 plus. What is I of 0 plus? I of 0 plus. What is I? Current through resistor. In step 2 only it is possible to find. For that, step 1, T equals 0 minus, what is the current flowing through the inductor? Current through the inductor, switch is open, right? Switch is open. Visualize the network again. Switch is open. T equals 0 minus, it is acting like a short circuit. This is open. That means 10 ohm is gone. The 10 and 10 are appearing in parallel. Current flowing through this 10 is nothing but current through inductor because it is acting like a short circuit. So current through short is nothing but current through 10 only. So 10, 10 parallel, equally divided again. So 1.5 divided by 2, there is nothing but 0.75 ampere. Getting all of you okay? Now, T equal to 0 plus, we need to construct equivalent. So how it looks like now, tell me. 1.5 ampere. This is 10 ohm. Now the switch is closed, therefore it is also 10 ohm. Now this is 10 ohm, but now the inductor is acting like what? A current source. Direction please. Downward direction. How much current is flowing? 0.75. This is a parallel inductor model. 0.75 ampere. Okay? 0.75 ampere parallel inductor is available. Now what is our objective actually here to find this current? I of 0 plus, right? I of 0 plus. Now since current source is in series with the 10 ohm, okay, can we neglect this 10 ohm? Any element in series with the current source can be neglected. This is 10 ohm, okay. Now this is what 10 ohm, okay. Now since it is neglected, if it is neglected, this 1.5 and 0.75 both are looking like parallel. Actually all elements are in parallel. If you neglect this, current source, 10 ohm, current source, all these four are in parallel because we are neglecting this. Now for the parallel combination of two current sources, you can replace by a single current source. 1.5 up, 0.75 down, therefore 0.75 up, 1.5 minus 0.75, 0.75 up, and 10 and 10 are in parallel with equal values, therefore equally divided, therefore I of 0 plus can be written as 1.5 minus, that is 0.75. This current is divided by, okay, equally, therefore 2. So 0.75 by 2, 0.375 ampere. That's it. Very simple. So if you find the tau value, what is tau for t greater than 0? Okay, switch is closed and current source is acting like open circuit, then looking into the network through L equivalent terminals, you can find RTH value. So RTH is nothing but, when you're looking to the network through L equivalent, switch is closed, this is open, then 10, 10 parallel, 10 parallel, 10, that result is in series with 10 because now you are looking into the network through these terminals, plus 10. So 5 plus 10, that is 15 ohm, and L equivalent is already given 15 millihenry. Therefore, tau will become 15 millihenry 10 power minus 3 divided by 15. Gone. 1 by tau is nothing but 1000 second inverse. This is second, but 1 by tau is nothing but 1000 second inverse. Now substitute all these things in this formula. Then what do you get the answer here? I of t will become I of infinity how much? You got 0.5. 0.5 minus 0.5 minus 0.375, okay, into e power minus 1000 t. Nothing but 0.5 minus 0.125 e power, okay, 0.125 e power minus 1000 t. This is what the response. So problems must be done in this manner. Understand all of it, okay? The formula is very simple to apply. You must be good at calculating tau value, okay, and good at drawing the t equal to 0 plus equivalent. It was also asked in GATE. It's a very simple one. It's a very simple one. $50 microfarad, 10 ohm. Okay, so asking here what is I of t for t greater than or equal to 0. Okay, so look at this problem now. Problem number 12, which was asked in gate. I of t. So initial charge on capacitor was given 2.5 millicoulomb. Okay, first you read that question carefully. If the charge initial on the capacitor is 2.5 millicoulomb, then the current I of t for t greater than or equal to 0. Simple. It's an RC series circuit, but it's a charged capacitor. Okay, so charged capacitor means what? You know that Vc of 0 minus already. Okay, Q by C, Q value is given, but voltage is nothing but Q by C. So 2.5 into 10 power minus 3 divided by 50 into 10 power minus 6. Okay, so what do you get here? What do you get here? So 5, 0.5, 0.5, 0.05 because 50 it is, right? So 0.05 into 10 power, it is 3. So 50 volts, right? 50 volts. That is what the information given. Based on that, we can find it. Now, I want actually I of t. That is nothing but a formula. Once again, I just consult the same formula. For this, I need I of infinity. What is I of infinity? Switch closed, capacitor is open. What is the current flowing here? 0. Okay. What is the I of 0 plus? What is I current through resistor or current through capacitor? Switch second step only it is possible to find. For that, in first step, you require voltage across the capacitor t equal to 0 minus. Because of the switching operation, it is not being charged, but it was already charged by 50 volts. Yes or no? Okay. So therefore, Vc of 0 minus, t equal to 0 minus, you need Vc of 0 minus. That value is already given. It was already given. But t equal to 0 plus, so the circuit will be drawn plus minus, the switch is closed. Okay, resistor remain resistor. The capacitor is acting like voltage source with a series capacitor model. Okay, this is 50 volts and this is 100 volts. And this is I of 0 plus. Okay, I of 0 plus and this is 10 ohm. Therefore, I of 0 plus is nothing but 100 volts minus 50 volts divided by 100 volts minus 50 volts divided by 10. Okay, how much you get? 50 by 10, that is nothing but 5 amperes. Getting all of you, okay? This is 5 amperes. So what about the tau? Tau value for t greater than or equal to 0. Tau value for t greater than or equal to 0. So C equivalent is nothing but 50 microfarad and RTH is nothing but 10. So tau is equal to 500 into 10 power. Okay? Is it kilo ohm or yes, ohms only, not kilo ohm, it is ohms only. 10 ohm. Okay? So 500 into 10 power minus 6 is 5000. So 1 by tau is nothing but 10 power 6 by 5000. What do you get? 3. That is 10 power 3 by 5, nothing but 2000. Okay, 1000 divided by, yes or no, all of you? What do you get here? 5000 divided by 50 microfarad. 50, it's not 500, okay, it's 50. 50. So this is 500 only. So you get 2000 second inverse, this is second. What is I of t? 5 into e power minus 2000 t. Okay, 2000 t amperes, that's it. Very, very simple problems, these are all. Okay, it was also asked in gate. Very simple one. It's a network of linear resistors and independent sources. There are two terminals given, AB, this is I and this is V. Now here are the characteristics of the same network. This is I and this is V. This is at 8 volt, this is at 4 milliampere, 0, 0. Let me read the question here. The voltage and current characteristics as shown, as seen from the terminal pair AB of the network of figure 1 is shown in figure 2. This is figure 2. Is shown in figure 2. If the inductance of value 6 millihenry is connected across terminal pair AB, then the time constant of the system will be simple. He is asking what is the tau of this particular system when there is an inductor connected. What is that value? 6 millihenry. When 6 millihenry inductor is connected across the terminals, okay. So what is the tau value is asking? Very simple question, okay. So let us look at this tau value. How do you find tau value? L equivalent by RTH. And this network is very clear, linear resistors and independent sources. So you have one inductor. It's a first order network for which we can find the time constant. The voltage current characteristics are given here in this particular figure, I and V relationship. But you know that L equivalent value is how much here? 6 millihenry. But RTH is to be calculated. What is the procedure to find RTH? Replace all independent sources by their internal resistances. Okay, and look into the network through AB terminals and find the equivalent resistance. But since we do not know the network configuration, okay, we can come to know the value of RTH only when the network configuration is given, otherwise the characteristics are given. You also know that RTH value is also calculated as VTH by I Nortons, yes or no? VOC by ISC. So from the characteristics we understand that wherever the current is 0, okay, that voltage is called what? Wherever the load current is 0, that voltage, load voltage is called as what? VTH. Okay. Whenever the voltage, load voltage is 0, that current is called what? I Nortons. So you can see that this value is nothing but VTH because this value is given VTH indirectly, and this value is given what? I Nortons. Therefore, you can calculate RTH value, that is VTH, 8 by 4. That is nothing but what? 8 by 4, nothing but 2 kilo ohm. Because 4 milliampere, 8 volts. Therefore, if you substitute all these values here, L equivalent is how much? 6 millihenry by 2 kilo ohm. 2 3 jar. 3 kilo. If it is coming to the numerator, then it becomes milli into milli, micro, and microsecond. 3 microsecond. There are 4 options given. Okay, the first option is 3 microsecond is the correct answer. Note on that, all of you. It was a very simple one. Sometimes the problems may be asked like this also. Just only on the time constant. Time constant for the first order system or first order network, we know very well. Either RTH into C equivalent or else L equivalent by okay. Question number 14. This one was also asked in GATE, previous GATE question it is. An RL circuit is initially relaxed. An RL circuit is initially relaxed. A step voltage is applied to it. If tau is the time constant of the circuit, the voltage across R and L will be same at time t equal to A tau B minus tau ln 1 by 2 C 1 by tau ln 2 D 1 by tau ln 1 by 2. Okay, so this is how actually the options are given. It's very simple. Okay, at what time the voltage across the resistor and voltage across the inductor will become same? That is what he is asking. Okay, what is the network given? RL circuit, right? So RL circuit, you know that RL circuit. The step input is given V, capital V, let us assume. This is R, this is L. Okay, so initially relaxed and the step voltage is applied to the circuit. So you are applying, assume that you are applying the step voltage at t equal to 0. This is VR, okay? This is VR, this is VL, plus minus, plus minus. Okay, so at what instant the voltage across resistor and the voltage across the inductor will be same? That's it. Okay, at what instant the voltage across the resistor will be same as voltage across inductor? This is what the question actually given. Okay, so first let us try to find RL series circuit. You also know that the current I of t you already determined, yes or no? So what is I of t actually? You got V by R 1 minus e power minus t by tau. Okay, equation 1, let us say. What is VR of t? I of t into R. So what do you get? V into 1 minus e power minus t by tau. Okay, equation 2. What is VL of t? L d I of t by dt. Differentiation. L into d by dt of this entire value. V by R of 1 minus e power minus t by tau. Okay, so what do you get here? VL. D by dt of this constant will become 0. D by dt of V by R into e power minus t by tau. That is nothing but what? L into V by R into, okay, when you differentiate e power minus t by tau, minus of minus will become plus. Yes or no, all of you? Minus of minus will become plus, but already minus 1 by tau. That means minus, okay, 1 by tau e power, okay, e power minus t by tau. I think you understand, all of you. Okay, but L by R is nothing but tau, but already 1 by tau. So therefore this will cancel. So minus V into e power minus t by tau is available. I hope you understand the point. Okay. Now, at what instant the voltage across the resistant voltage across the inductor is same, is asking. Therefore, let us call it equation 3. Now 2 is equal to 3. Let us try to find. What is 2 actually here? V into 1 minus e power minus t by tau, which is equal to minus V. Okay, minus V. But look at this, all of you. Already you got d by dt of minus V by R, that is minus, but minus t by tau will become minus 1 by tau. Therefore, is it minus now? Plus? Plus only, right? Not minus. Okay, this is plus only, right? So you get plus V into e power minus t by tau. Simple. So what is this? V minus V e power minus t by tau is equal to V e power minus t by tau. That's it. So if you take it this side, 2 into V, I mean, you can cancel even V also, okay? Otherwise, you can say here 1 minus, okay? Here only you can cancel, right? Okay, 1 minus e power minus t by tau and e power minus t by tau. So 2 into e power minus 2 into e power minus t by tau is equal to 1. So e power minus t by tau is equal to 1 by 2. Minus t by tau is equal to ln natural logarithm, okay? 1 by 2. So T is equal to, what do you get? T is equal to what? T is equal to, this is tau, already it is going tau and minus also, minus tau ln 1 by 2. Option B is correct. You understand all of you, okay? Option B is correct. Option B is correct. Understand all of you, okay? Note down that quickly. Very simple problem. Next we will switch on to 15th problem. Quickly note down. We will discuss 15th problem. We will discuss 15th problem. It's a very interesting problem, 15th one also. This one also asked in GATE. There is a 20 ohm resistor. Okay. Here is a resistor, capital R. It's a coil with 10 Henry, 40 ohm. One, two. Right. So question number 1 in this, the first question is the capital R value. Capital R value. The second question is, using the capital R value found in the first question, what could be the time taken for 95% of the energy to be dissipated? So it's very clear, all of you. Just read the question clearly first. A coil of inductance 10 Henry and resistance 40 ohm. Coil, it's a practical inductor. Coil is not simply 10 Henry. It is 10 Henry and 40 ohm. Together it is a coil. Because you already know what is a coil. Coil is nothing but what? Okay, a coil consists of inductance as well as some resistance. Okay, 10 Henry and 40 ohm. As shown in figure. After the switch S has been in contact with point 1, connecting point 1. Okay, for a very long time, it is moved to point 2 at t equal to 0. That means you are operating the switch from 1 to 2. So it's very clear. Okay, according to the data given, I can just draw this. At t equal to 0, the switch is moved from position 1 to position 2. Now there are two questions asked actually here. If at t equal to 0 plus, the voltage across the coil, okay, is given as 120 volts, what is the R value? Okay. And second question is, what for the R value that is obtained in the above question, that is nothing but here the first question, then the time taken for 95% of the stored energy to be dissipated is close to. So 4 options were given. Okay. That means use this information, that R, and find what is the time t for which, the 95% of the energy that is stored in the inductor to be dissipated. Okay. So just read the question carefully and try to understand the question first. And the answer is very simple. The solution is very simple if you understand the question carefully. Okay. If you understand the question clearly, then the answer is very simple. Okay. So what is the data given to find capital R value? He has given that the voltage across the coil. What do you mean by coil here? Both resistance as well as inductance. Okay. So this is the coil actually. This is the coil. Across the coil, the voltage is given how much here? 120 volts. He did not mention whether it is a plus minus or minus plus. We do not know that. But it's clear that voltage across the coil is 120 volts. Okay, at t equal to 0 plus. So what shall we do now? Because at t equal to 0 plus the information is given, let us try to construct the t equal to 0 plus equivalent. What is the procedure to find t equal to 0 plus equivalent here? Look at this. Okay, t equal to 0 plus equivalent. T equal to 0 plus equivalent, if you want to draw, you must know what is current flowing through the t equal to, inductor at t equal to 0 minus. Switch is at 1 for a long time. Inductor is acting like a short. And what is the voltage value given on here? It is 120 volts. Okay, 120 volts. This is 120 volts. Switch is at 1. Okay, switch is at 1 and inductor is acting like a short circuit. So 120 by 20 plus 40. 120 by 20 plus 40. How much here? This is 60 and therefore 2 amperes. Clear? Use this information and try to find the equivalent circuit at t equal to 0 plus. So what is the t equal to 0 plus equivalent? This is t equal to 0 minus. Okay. Now the switch is at 2. This is 20 ohm. Inductor is acting like what? The current source with the parallel inductor model is the remaining resistor. This is capital R. Clear all of you? Okay. What is the voltage given here? 120 volts. What is the current value? 2 amperes. This is 40 ohm. This is capital R. Okay. So the voltage information is given here. Okay. But voltage polarities are not given. Understand all of you? Okay. Voltage polarities are not given. So what we do is, first we take plus minus. Okay. This is plus, this is minus. And then we will see. Okay. Then we will see. This is plus minus the voltage. Then we will see if it is not feasible, then we will change the polarities. Okay. So what is that voltage here? This voltage is nothing but voltage across this and voltage across this only. Yes or no, all of you? The voltage between these 2 points, because the coil voltage is given. What is the coil? Coil means these 2 terminals. So the voltage between these 2 terminals is 120 volts. Now voltage of this and this, if you add, you will get this 120 volts. But what is the voltage of it? The current is flowing like this. This is plus, this is minus, this is 2R. This is plus, this is minus. 2 into 20. How much it is? 40 volts. Yes or no, all of you? Okay. So 120 volts. If I assume that plus minus polarities, okay, then what will you get here? Tell me, all of you. Now I get 120 is equal to, touching negative first, minus 40, touching negative, minus 2R. So what do you get here? Minus 2R is equal to 120 plus 40, 160. Now R is equal to minus 80 ohm. Okay. So you got a negative value. Negative, is it feasible or is it feasible? Negative value is not feasible. Therefore, this is not a feasible value. Minus 80 is not a feasible value. That means the polarities what you have assumed plus minus are wrong because he has not mentioned. Okay. These are wrong. If you assume it is minus plus polarities, let us see what will happen. Then what do you get here? You get 120 is equal to, here, touching concept or KVL, you can apply. From here I am moving, I am touching plus first. So 2R plus 40. So what will you get here? 2R is equal to 120 minus 40, nothing but 80. Therefore R is equal to 40 ohm. So this is feasible value. So R is equal to 40 ohm. Okay. A simple logic that we need to apply here. He has not mentioned the polarities of the voltage across the coil. So since he has not mentioned, I have no option. First, let me check with plus minus. If it is feasible, I'll go with that. If it is not feasible, I'll change the polarities and go. That's it. Very simple. So you must be very careful when the voltage polarities are not mentioned. You must be very, very careful. Okay. So what is the second question? At which time, at which instant, the amount of energy stored in the inductor is dissipated, 95% dissipated. What do you mean by 95% dissipated? 95% dissipated, 95% of energy in the coil dissipated is nothing but 5% of W of 0 remain. Yes or no, all of you? See, 95% dissipated means what? What is the amount left over? Only 5% left over. Yes or no? Okay. So what is the amount of energy initially WL of 0, let us say. Then 95% of WL of 0 plus or 0 dissipated is nothing but 5% of WL of 0 remained stored. Okay, remain stored. Remain stored. Understand all of you? Okay. So if I just find the energy, okay, and initial energy, and at what instant that 5% of that initial energy is stored or remain with the inductor, if I'm able to find, then I can achieve that particular, answer. Yes or no, all of you? Okay. So what is that WL of 0 plus, first of all, is nothing but half L I of 0 whole square. What is that half L? How much here? L value 10. What is that I of 0, Nana? Here already you got what is I of 0? 2 amperes. Yes or no, all of you? Okay. I of 0 is nothing but what? Here I of 0 plus or 0 minus, both are same. So 0 minus how much it is? 2. 2 square. So 2, that is 20 joule. Is it clear? Okay. So 95% of the energy dissipated is nothing but 5% remain. So 5% of WL of 0 is nothing but, okay, 5% of, okay, 20, nothing but how much it is? 1 joule. So let me just check the 1 joule at what instant I'm getting here. Okay. For that, what we do is, anytime, generally when the function is given, f of t is there, some value is given, t square plus 2t plus 1. Okay, the problems may be asked in two different ways. One is, f of 1 is how much, or else, at what instant this f of t is going to be some 10. That means, in one category, he may be asking you the instantaneous value of this f. In the other category, at what instant the value of this function is going to be some value. There are two kinds of problems you may get, right? So now, in this particular case, you have an energy. What is the energy actually here? WL of t, half L I of t whole square, I of t square. Okay. Now this is what the energy function. Now, if you are able to find WL of t, for which you require I of t square. Okay, I know how to find I of t, that's not a big deal for me. Time response I need to find. If I'm able to find WL of t, at what instant of this time t, the WL of t is going to be 1 joule, okay, I can easily find. Okay, therefore, I'll come back to this later, okay, in that similar concept, okay, f of t. At what instant, what the value of f of t is going to be 10, like that, okay, at what instant now W of t, WL of t is going to be 1 joule. This is what the question actually is asking. But to find this, definitely you require WL of t first of all. So I'm just taking this formula clearly. Let me find what is I of t. What is I actually? Current through the inductor. Yes or no, all of you? Already given in the circuit itself. What is the current through the inductor is, okay. You can find I of t. Assume that I of t is the current through the inductor. Then I of t is nothing but I of infinity. What is I of infinity? Minus I of infinity minus I of 0 plus into e power minus t by tau. You know that this is 0. You know that this is 0. This is what 2 into e power minus t by tau. What is the tau value here? Tau value I can find easily. What is the tau value actually? The switch is closed. Okay, the switch is closed and you are looking into the network through L equivalent terminals. When you look into the network through L equivalent terminals, okay, t by tau and 2 into e power minus t by tau. Okay, let me find what is the tau value. Tau for t greater than 0. Understand? Okay, tau for t greater than 0. So tau value can be calculated here when the switch is closed. You are looking into the network through L equivalent. When you look into the network through L equivalent terminals, 20R and this 40 all are looking like, series. Yes or no, all of you? So just imagine here the second question, you are in need of R value. Otherwise you cannot find it. That means there is a link. Question 2 solution is linked with the question 1 solution. That is why these kind of questions are called linked answer questions. Okay, linked answer based questions. Okay, so question 1 if you solve, then only you can able to solve question 2 here. Sometimes the questions might be coming in the linked answer based. Nowadays in the gate questions, linked answer based are not coming, but sometimes common data questions will be asked. So the all common data questions can be, in that also you may be in need of finding all these multiple answers. So tau is nothing but what? Tau is nothing but L equivalent by RTH. So what is L equivalent actually here? 10. What is RTH here? 20 plus capital R plus 40. So 20 plus capital R plus 40. But already you know this capital R value. 40 plus 40 plus 20, 100. So 1 by 10 second. Then 1 by tau is nothing but 10 second inverse. If you substitute all these things here, then what will you get, Nana? Tell me. Here I of t will become, okay, 2 into e power minus 10t. Then WL of t will become half. L is nothing but how much? 10. Okay, I of t square, 2 e power minus 10t whole square. Okay, then you get here 2 5 ja, and already 2 okay, 2 square 4, 5 into, therefore 20 e power minus 20t, 10 2 ja. Okay, now you got WL of t as this one. Now at what instant the 5% of initial energy remain with this? Okay, so WL of 0, okay, you already know this value, right? At what instant? At what instant this value is going to become 1 joule. So therefore, you can substitute here from this value 1 joule, okay, is equal to 20 e power minus 20t. Now I would like to find this t value. So what is that value? Tell me. Minus 20t is nothing but, okay, or else you can say e power minus 20t is nothing but what? 1 by 20. Minus 20t is nothing but ln 1 by 20. Okay, then t is nothing but minus 1 by 20 ln 1 by 20. So please calculate. I think all of you are having calculators. You can easily find this value. This is 0.149 seconds. Approximately it is 0.15 seconds. Okay, so if you are looking at the options, option B is correct. I hope all of you understand the solution here clearly. Okay, if you read the question carefully, the second question, at what instant the 95% of the energy is dissipated, nothing but 5% of the energy remains stored. Okay, for that I found the energy. To find the energy as a function of time, I need the current as a function of time. For that I found the time response. To find, I have the procedure to find the formula, apply formula, because it's the first order circuit and exit by the step input. I can apply the formula, yes or no? Then I found I of t, then WL of t, then WL of t value, because I know the instantaneous value of this particular function, that is 1 joule. But at what instant this 1 joule is coming, I need to find. If I substitute here, I get the time value 0.15 seconds. So students, this is how the problems are. I have solved different varieties of problems. Okay, 2 switches I have used. Okay, and different dependent source problem I have used. Okay, and different varieties of problems I have covered. Okay, so look at this. There is no end for the problems. You have to practice. Okay, as many problems as possible. Okay, so I stop the session here.